In this video, we'll continue the topic of solving quadratic equations in pre-calculus algebra. This is an important pre-calculus algebra topic. In the previous video, we did an overview of what a quadratic equation was, and we did an overview of the 4 different methods of solving a quadratic. That's factoring, using the square root property, and then the last 2 are completing the square and using the quadratic formula. And those are the 2 methods we're going to look at now. Now, this completing the square, if you have in mind the idea of what we're doing here, we're trying to get something, a quadratic equation, in a format like this, x squared equals 25. And if you have in mind what the goal is, then doing this work might be a little easier. But I will say it is a process. You'll either need to memorize the steps, not advised, but you could memorize the steps, or you could keep in mind the goal, and then you might be able to follow through the process without actually memorizing the steps. But the goal is to isolate the x term, because if I isolate the x term, I can use the square root property to get that this is x equals 5 or -5, right? Or an even better example would look like this. If I have x plus 2 squared equals 49, I've isolated that square term. So I'm going to do the square root of both sides. And the square root of x plus 2 squared is x plus 2. The square root of 49 is 7, so x plus 2 is either 7 or negative 7. To solve for x, I'd subtract 2 from both sides, so I have -2 plus 7 or -2 minus 7. So that would give me x equals 5, x equals -9. That's just a rough, quick overview of the square root property. But what I'm doing when I complete the square is I'm trying to get something in this format that we had, the x plus 2 quantity squared equals some value, some constant, some number. So when I look at the process of an example, the first step is to figure out a constant I can add that would make this a perfect square. So when I look at this x squared minus 10x, I'm thinking through what constant can I add to x squared minus 10x so that I get a perfect square. And here's the magic recipe. I'm going to take that coefficient of x, I'm going to cut it in half. That'd give me -5, and then I'm going to square it. You might say that out loud to yourself. Write it down. Cut it in half and square it. How do you find that constant that you add in? Cut it in half and square it. Say that out loud to yourself a few times. Say it out loud to yourself as we do it, and it might make more and more sense. Now, if I cut the -10 in half, you could even use a calculator if you needed to, but -10 divided by 2 is going to be -5. And -5 squared, it's not -25, it's -5 times -5, which is +25. So it looks like +25 is the number I could add. What term should be added to x squared minus 10x so that it becomes a perfect square? The answer is 25. And now if I add that in and then factor it, here's what I'd have. I already had the x squared minus 10x. And what I found is that I want to add in the 25 and watch what happens when I do that. When I go to factor this, I'm thinking what number multiplies to 25 and adds to negative 10? It's negative 5 and negative 5. So when I factor this, I'd get x minus 5 times x minus 5, or just x minus 5 quantity squared. So the first part, what number do you add? We added the 25, and then the second part, factor it. X minus 5 quantity squared. Let's take this a step further and see how we'd actually solve. If we want to solve this x squared minus 6x minus 11 with the completing the square property, the first thing I want to do is isolate all the x's. Get all the x's on one side. So I want this x squared minus 6x on one side. So I need to move out that negative 11. To move the negative 11, I can add 11 to both sides. So I have x squared minus 6x equals 11. Now I'm going to save myself a little bit of trouble here by leaving a little space here, because the next step is going to be to add that magic number, that number that makes this a perfect square. What is that number? So I'm going to just write the steps out here. Add the magic constant to both sides. And the magic constant, what I mean by that is that constant that I can add to x squared minus 6x to make it a perfect square. How do I find that? I take the negative 6, cut it in half, that's negative 3, and square it. Take the negative 6 and cut it in half. There's a negative 3. When I square it, it's negative 3 times negative 3, so plus 9. Now you're familiar enough with equations to remember that I can't just add that pink 9 in and expect this equation to still be balanced. So I'm going to need to add the 9 to the other side as well. Now the third step is to factor and solve. So to factor this, I'm thinking, what's the number I can multiply to 9 and add to negative 6? It's going to be negative 3. And by the way, it is no coincidence. Let me point this out now. You see that negative 3? That negative 6 cut in half before I squared it, that's the actual term. And if we've done this correctly, it always works like that. But that's that number that we get when we factor. So as you go, if you do this negative 6 cut in half, that's the number that will always fit here. So the x minus 3 times x minus 3 is what, because we get them repeated, right? So x, the factoring would be x minus 3 times x minus 3 equals 11 plus 9. Now I'm ready to use the square root property. I should probably step back and let me say this. Let me erase that and solve and be even more descriptive. Because to solve it, I'm going to apply the square root property. Once I get it factored in a perfect square, I'm going to apply the square root property to solve it. So I get that x minus 3 square rooted and squared, that square and square root undo each other. So I'm left with x minus 3 equals plus or minus square root of 20. Now 20 breaks down to a perfect square 4, and a 5 left over. So when I do that square root simplifying, I could do the prime factorization. So 20 breaks down to a 2 times 5. Those two 2's come out. So this shows me that how to simplify the square root of 20 as 2 square root of 5. You might have also noticed this, now that you've done a few of these, maybe you're recognizing that instead of going all the way to a prime factor, if I get a perfect square, like this 4, that I could stop there, right? Let me show you what I mean by that. The square root of 20. I could write this as that perfect square 4 divides into 20 times 5. 20 is equivalent to 4 times 5. So the perfect square 4 times the square root of 5. The square root of 4 is 2, and then the square root of 5 doesn't simplify. So I have x minus 3 is plus or minus 2 square root of 5. The last step in applying the square root property is going to be to solve for x. So I'm going to add 3 to both sides, and I get that x equals 3 plus or minus 2 square root of 5. So that's 3 plus 2 square root of 5, or 3 minus 2 square root of 5. And that's it. Let's look at a couple more examples. Here's one. If I want to apply the square root property, I'm going to isolate the x squared and the x together. So isolate the x's. So I'm going to have to add 2 to both sides. That leaves me 3x squared minus 2x equals 2. But in addition to what I've done here, I've got to isolate. Now I've got to get rid of that 3 because I want that x squared to be 1x squared. So this is the first one we've had like this. What I'm going to have to do is divide everything by 3. It's okay if it doesn't look pretty. What I'm going to do is then see that this 3 over 3 leaves me with an x squared, and then this x term is a 2/3 x equals 2/3. It's okay to have fractions in there. Don't panic about that. When I cut that 2/3 in half, so it's like saying divided by 2. That's the same thing as saying 2/3 divided by 2, right? So it's really what I'm doing is 2/3 times a half. I think this is the best approach to use when we've got a fraction. You think of what is 1/2 of 2/3. Cut the 2/3 in half. What does that mean to do? It means to multiply the 2/3 times a half. 1/2 of 2/3, 2/3 times a half would be 2 times 1 over 3 times 2. When I reduce that, I'd get 1/3. So there's the 2/3 cut in half. And now I'm going to square that to get 1/9. So do you see then that 1/9 is the piece that I'm going to add to both sides? So on the left, I've got x squared minus 2/3 x plus 1/9. And now when I'm factoring, I'm thinking, what can I multiply to get 1/9? Add to get negative 2/3. And again, if we go back to this idea, oh, and you know what, I see I took a little bit of a shortcut. I'm going to go back and fix that. this was a minus, right? It didn't change the value I got here, but let me make sure that we keep that negative 2/3 in there. When we square it, it doesn't matter, right? When we square it, we still get the 1/9. But I want to keep that so that you can see that this term that I get when I factor is that negative 1/3. The magic number that I could get to factor this, the I don't know what I was writing here. I'm so sorry. I'm getting a little distracted because I said it, but then I didn't write it here this way. What we were doing when we were factoring was looking for two numbers that multiply to positive 1/9 and add to negative 2/3, right? And the answer was negative 1/3. What I was trying to demonstrate here is that negative 1/3 is what we got when we cut the negative 2/3 in half. And that always works out to be the missing factor. Next, I'm going to add 2/3 to 2/9. To do that, I need to get a common denominator, which is 9. So that's 6/9 added to 1/9. But you could also use your calculator to do that and just type it in 2 fraction 3 plus 1 fraction 9 to get the 7/9. So if the fractions are throwing you off, don't let that hold you back. You can do that without the calculator, or you could do it with a calculator. Now I'm going to apply the square root property. So I get the square root of x squared minus 1/3 squared is x squared minus 1/3 equals plus or minus square root of 7/9. So I'll add 1/3 to both sides. I don't know why I had a square in there. I am so sorry. This video I am just really blotching. I'm not going to go back and remake it, but I hope maybe you've noticed this as we were going along. As you can tell, I'm struggling to talk here. I've got this cough going and a number of things happening. So I'm sorry I've gotten a little distracted. I hope that all looks clear to you and you can follow what was going on and why this doesn't have a square is because the square goes here, right? But this x minus 3 equals this plus or minus square root of 7/9. When I add the 1/3 to both sides, I'm going to have x equals plus or minus the square root of 7/9. Now, that's going to be the square root of 7 over the square root of 9, which is the square root of 7 over 3, because the square root of 9 is 3, right? So when I add the 1/3 to both sides, I'm going to have 1/3 plus or minus the square root of 7 over 3. So I could write that 1 plus the square root of 7 over 3, 1 minus the square root of 7 over 3. I hope that example makes sense to you. I hope I didn't confuse it too much for you and that you could follow along with that example, but do let me know if you have any questions about the example.